No, thanks a lot. And thanks for having me. And maybe just to echo what you have been also listening, um, mapping deprivation, also linking back to what you heard at the very start of the session from Dennis, from UN Habitat, developing data to support SDGs is a very complex thing to do. So everybody typically agrees what is a tree, but very few people. It's not very easy to say what should be now reported, maybe under SDG 11, what is deprived, what is not deprived, what you heard also from Maxwell before. And a lot of the problems comes also from this binary understanding of what is deprived and not deprived. I will dive in this presentation into a user and data-centric approach for artificial intelligence and mapping of informal areas, very much responding to SDG 11.1.1 monitoring, which is one of the work we are doing, but also being part of the larger ID maps context. Thanks for switching to the next slide. So one of the major problem is that we typically train, and that's a typically sort of computer science, Earth observation-based approach. So we train our models with whatever data we can get, and it's often ending into rubbish in, rubbish out pipelines. Not really understanding the complexity of spaces, not really understanding the diversity of data we feed into our models. And that's what we are trying to really to help and to stop and to find a different solution space for bringing more data quality into Earth observation-based models. And starting in the local scale of understanding first what is locally understood as deprived, which should be in the end reported under SDG 11.1.1. And therefore we have to set up. So we start with a set of pilot cities, which are 8 diverse cities. You can criticize their selection, which has to do with they're mainly primary cities, or they are primary cities, because this was our first starting point of getting access to data, getting access to stakeholders. But we also started with the more difficult to map cities and the more easy to map cities. I made some literature review some years ago, and I found that almost 50% of the Earth observations studies mapping deprivation, slums, informal settlements always work with 2 cities, which is Nairobi and Mumbai, because they are relatively easy, distinct morphologies, and data are available or easier available. While you have more complex to map cities, for example, Buenos Aires. So we started with these pilot cities to develop our model approach, and with, as I said, with very much focusing on SDG 11 indicator. And then we have this expansion cities, which we use as a much more diverse set of cities, very different geographies, very small cities, very also very unmapped cities. For example, nobody has ever mapped like cities like I'm sorry, like Guinea, which is basically there is no knowledge about the morphologies. Next, please. So this is done by a large team. Just acknowledge, I will not go into details of people working on the methods, but also our advisory board with known faces, also from this morning, Dana in the room, colleague from UN Statistics, etc. Next, please. So what we are starting to do, and we say, okay, what we want to produce is a cost-efficient approach, a scalable approach, and which is transferable. So cost-efficient has to do that we leave this pathway of working with commercial, very high-resolution data. We often say, okay, if you want to map a city of Nairobi with commercial data sets, like the type of images you see on Google Maps, they cost you roughly about $20 per square kilometer. Taking a city of Nairobi, which is about 1,000 square kilometer, you pay for one image $20,000. That's not scalable. So we are looking into really low cost 10-meter resolution Sentinel images, comparing it also with PlanetScope images, which are available for research. But the main starting point were the living labs and bringing local stakeholders together and understanding information needs, but also what should not be mapped, how to generate reference data that are locally meaningful, representing the diversity of urban spaces. We do this in an efficient cloud computation infrastructure, which is Geodias, which is a European cloud computation infrastructure, where you have all the images in the infrastructure. You can deploy your algorithms and simply run them over images, which is quite computational efficient. Next, please. So what we in the end map are three major products, which are the settlement extend. We in the end also grid them into 100-meter grid to not show the exact boundaries out of ethical reasons. We also look to the dynamics across settlements, which is an important question also for general urban development, but also for SDG monitoring. But we also want to not leave it in the binary space, but also go into how diverse are these spaces, what are different issues of the spaces. I won't go into details in this presentations, and we aggregated into slum metrics. So if you can stay with the last, I'm almost there. So we also respond to very specific user questions, like in Argentina, where we support the National Slum Registry to identify places which are mapped and included. And in the end, if they're included, it means they have 10 years of guarantee to be not evicted. Next, please. So we do this, and that's the sort of the main crucial element of our approach is we developed a very lightweighted network, which is a state of the art, but really reducing it to a minimal to be computational efficient. The most important element is our data portal, which allows us to produce a first model output based on our first set of reference data, bring it back to the city actors and ask them, so what is now correct and what is wrong in our first model, and get feedback in our portal of our first model output. This feedback is used to improve the reference data and gradually improve our set of reference data to make it more locally meaningful and train the model to predict as much as possible, with its limitations of what Earth observation can do, the patterns of spaces that should be reported under SDG 11.1. We do this then employ this also to expansion cities to see how it transfers to unseen places. And in the next step, we are running it also on experiments to predict whole countries, which are our expansion countries. Next, please. If you want to play it very quickly, it shows just a demo on, you can also play it maybe quicker, how to have a couple of cities. You as a user, you can zoom into this portal. You can see our mapping output, and you can basically then interact with our portal. I'm in a presentation, online presentation. I have some colleagues jumping into my room, sorry. And you can basically see how our model sort of relate with the reference data set. And users can then sort of provide us feedback in terms of, okay, I know this area is actually would be locally seen to be reported under SDG 11.1. We have it in a moment as a binary classification, but also providing feedback in terms of what are the specific deprivation characteristics of the space. It will be added to our database and will be included in the next run of the model. Next, please. So basically, I won't go into details, but basically what we show is that this step-by-step improving of the reference data contributes to an improved mapping accuracy. We also publishing this data set as a benchmark data set to stimulate the community to pick it up and to further develop models, but also adding reference data set to this in the future. Next, please. So our future work is really going into the more country scale model, as you see in the example of Argentina, and where you have actually a contradiction between the presently reported data under SDG, which assumes that the SDG indicator 1111 goes down, meaning the number of people living in informal settlements and slums are reducing, while the local data set, which is a ground-based data set from our partner organization in Argentina, show that they're actually increasing. So we really want to develop what I call this large-scale regional country-scale models, but also not only developing models, but also interacting with local partners to transfer this knowledge to local partners, like we're working with various local governments to see how they can use models. We also train partners of local governments to work with such models. And gradually we want to sort of develop more and more reference data that we come to a more continental and at the end a global scale model with an improved and diverse set of reference data. I think that's my end with some illustration from all the living labs you see, in which is a nice connection to Nisera because she's on one of the pictures. And thanks a lot for listening.